Welcome back to another deep dive from Peaceful Rooster Experience. This time, we're going to be diving into the world of streaming databases.
Oh, interesting.
It's fascinating.
Yeah.
We're so used to databases being these like static things,
Right.
but what happens when the data is constantly changing?
Yeah.
Like imagine trying to track a livestock ticker or a self-driving car navigating traffic. All of that data is coming in so fast.
Right.
That's where streaming databases come in, right?
Exactly.
It can make sense of information in real time.
Yeah.
And to guide us through this fast-moving landscape, we've got our expert who, well, they know this stuff inside and out.
I'm happy to be here. And yeah, you hit the nail on the head. Streaming databases are all about embracing that dynamic nature of data, It's not about analyzing what happened yesterday anymore. It's about understanding what's happening right now so we can make decisions instantly.
Okay, so for those of us who haven't jumped into the data stream yet, what exactly are streaming databases? Like, I get the concept of regular databases,
Yeah.
but how are these different?
So imagine you're running a busy website and you want to track user activity.
Okay,
A traditional database would be like taking a snapshot of that activity once a day.
gotcha.
It tells you what happened,
Right.
but it doesn't give you that real-time view.
Uh-huh.
A streaming database, though, that's like having a live feed of all that activity, constantly updating as users are clicking, scrolling, interacting.
So it's like the difference between checking your email once a day
Yes,
versus having new messages pop up instantly.
exactly.
Okay, yeah, that makes sense.
Yeah.
But I'm curious, why not just use a regular database and just update it really frequently?
Hmm.
Wouldn't that kind of achieve the same thing?
It's not just about the speed.
Yep.
It's about a fundamental shift in how we process information.
Right.
Traditional databases, they're optimized for storing and querying large data sets,
Uh-huh.
but they're not designed for that constant influx of new data coming in.
Right.
Imagine trying to fit a fire hose into a teacup.
Oh, yeah.
It's just not going to work.
Right, right.
Streaming databases, though, they're built from the ground up to handle continuous data streams, processing information as it arrives.
So they're designed to kind of, I don't know, embrace the chaos.
Yes, exactly.
All right, I'm starting to see the difference.
Good.
But how does this whole streaming data pipeline, how does it actually work in practice? Like, what are the moving parts?
Think of it like a factory assembly line.
Okay.
The first stage is ingestion.
Ingestion, right?
This is where all that raw data comes pouring in from all sorts of sources.
All right.
Sensors, websites, applications, you name it.
Mm-hmm.
Think of Apache Kafka as the conveyor belt that's bringing in that constant stream of raw materials.
Kafka. Okay.
Yeah.
That's a name I've heard thrown around a lot in the data world.
For sure.
So it's like the central nervous system gathering all the
Features.
signals.
It acts as a high-throughput, low-latency message broker, which basically means it makes sure that data gets delivered quickly and reliably.
Gotcha.
But raw data isn't that useful on its own.
True.
That's where the next stage comes in processing.
Right. Right.
We make sense of all that chaos.
Okay.
Turn that raw data into something we can actually use precisely. Tools like Apache Flink and Rising Wave, they step in like the factory workers, transforming, enriching, and analyzing that data stream.
Flink and Rising Wave. Okay. So
Yeah.
they're like the brains of the operation.
You could say that.
And how do materialized views fit into this whole process?
Wow, those are neat.
Yeah, they sound kind of magical.
So imagine you're tracking website traffic, right?
Yeah.
And you want to know the total number of unique visitors in real time.
Mm-hmm.
A materialized view would be like having a dedicated counter that's constantly updating that number
Wow.
as new visitors arrive.
Yeah.
No need to recalculate the whole thing every time. The materialized view just keeps it ready to go.
This is pretty slick.
And you can define these views using regular SQL queries, making them very approachable.
Nice.
So, for instance, with Rising Wave, you could write a simple SQL query to calculate a 1-minute average temperature from all your sensor data
Yeah.
and have that average constantly updated as new readings are coming in.
It's like having a shortcut to the information you need most.
Yeah,
Always up to date.
exactly.
I like it.
Good.
But I have to admit, when we start talking about event time versus processing time,
Yeah.
my brain starts to feel a little overloaded.
Sure.
Is there like a simple way to wrap my head around these concepts?
Absolutely. Let's say you're tracking orders for an online store.
Right.
The event time is the moment a customer clicks that buy button, you know?
Okay.
But because of network delays or other stuff,
Right.
that order information might not reach your database immediately.
Right.
The processing time is when the database actually gets that information and processes it.
Gotcha. So event time's like the real world time,
Yeah.
and processing time is the database's own clock.
Exactly. But why does that distinction even matter?
Right.
Wouldn't things eventually even out anyway?
Not always, and sometimes it can make a big difference.
Mm.
Imagine you're analyzing stock trades.
Okay.
The order those trades happen in,
Yeah.
that's crucial
Right.
for understanding market movements, you know?
Uh-huh.
If we just rely on processing time,
Yeah.
we might get a skewed view of what actually went down.
I see.
Event time lets us reconstruct the true timeline,
Okay.
even if the data comes in out of order.
Ah, that makes sense.
Yeah.
It's like putting together a puzzle
Yes.
where the pieces come in all jumbled up, but you still need to see the complete picture.
Exactly.
In the right order.
And I bet this is where that exactly once semantics thing becomes really important.
Yeah.
Because if we're talking about financial transactions or other sensitive data,
Right.
we can't have any double counting or missing entries.
Mhm.
You got it. Exactly. Once semantics is all about ensuring that each event is processed exactly once.
Okay.
No more, no less.
Think of it like sending an email. You want it to get there once,
Right?
not get lost, and not end up with multiple copies.
Yeah.
Doing that in a distributed system, though,
Yeah,
that's super complex.
I bet.
But it's vital for keeping the data accurate.
Makes sense.
It involves things like checkpointing, which is like saving your progress in a video game,
Oh, okay.
and idempotency, which makes sure that an operation can be repeated without messing things up.
So it's like careful bookkeeping
Yeah,
combined with some clever coding
exactly.
to make sure nothing gets lost or duplicated,
You got it.
like a safety net for your data stream.
Exactly.
Now, before we get too deep into the technical stuff,
Sure.
I'm curious, are there any real-world examples of how streaming databases are making a difference? Like, where are they really shining?
They're popping up everywhere.
No.
One area where they're making a big impact is the Internet of Things.
Okay.
Imagine a smart factory with sensors constantly checking on the equipment. A streaming database can analyze that data as it comes in,
Yeah.
detecting anomalies that could mean there's a problem brewing.
So it's like having a digital doctor
Yeah,
constantly monitoring the factory's vital signs.
exactly. And by finding those issues before they become big breakdowns, companies can save a lot of money and keep things running smoothly.
Right.
And this real-time monitoring isn't just for machines either.
Oh, interesting.
Think about healthcare streaming databases could be used to analyze patient data from wearables,
Wow.
letting doctors monitor vital signs remotely and step in if they need to.
It's like having a virtual health guardian angel
Yeah.
watching over you 24/7.
Exactly.
Okay, I'm blown away by the potential here.
It's pretty amazing.
But let's not forget about the rest of us, regular folks.
Right.
How are streaming databases impacting our everyday lives?
Think about those recommendations you get on streaming services or shopping sites,
Mhm.
Those are often powered by streaming databases.
Oh, wow.
Analyzing your viewing history or purchasing habits in real time
Really?
to suggest stuff you might like.
It's like having a personal shopper
Yeah.
or entertainment curator who knows your taste better than you do.
Exactly.
It's impressive and a little creepy at the same time.
Yeah, a little bit.
But it does explain those uncannily accurate recommendations I keep getting.
Yeah, exactly.
Okay, I'm hooked. This whole streaming database thing is fascinating.
It is.
But before we move on,
Sure.
I think it would be helpful to talk about the specific tools that are making all this possible.
Great idea. Each tool has its strengths and weaknesses, so it's a pretty diverse landscape.
Also, let's dive into those next.
Sounds good. We were just talking about the tools that make all of this streaming magic happen, right? We already touched on Apache Kafka, which is like the central nervous system,
Yeah.
gathering data from everywhere.
Yeah, Kafka's great at getting all that data flowing, but it's like, having a fire hose without a nozzle.
Right.
We need something to direct that stream.
Yeah.
And make it useful.
Yeah.
So let's talk about those processing powerhouses.
Okay.
What are some of the big names in the streaming world?
Well, two of the most popular and powerful tools out there are Apache Flink and Rising Wave.
Okay.
They both excel at handling high-volume data streams, and doing complex calculations in real time.
Link and Rising Wave. They're
Yeah.
like the dynamic duo of streaming data processing.
You could say that.
Tell me more about what makes each of them unique.
Let's start with Apache Flink.
Okay.
It's really known for its speed and its ability to handle complex event processing.
Complex event processing.
Yes. Yeah, like imagine you're tracking user behavior on a website
Hmm.
and you want to identify users who are likely to abandon their shopping cart.
Right.
Flink can analyze clicks, page views, all those interactions
Yeah.
in real time, to identify patterns that suggest a user's about to leave.
Interesting.
And then it can trigger an action, like maybe show them a targeted offer or a helpful message to try and keep them engaged.
So it's like having a virtual sales assistant.
Yeah.
Who can anticipate a customer's needs and step in at just the right moment?
Exactly.
That's pretty impressive. But what about Rising Wave? What are its superpowers?
Rising Wave is all about making streaming data analysis accessible to more people,
Okay.
especially those who are comfortable with SQL.
Right.
It provides a familiar SQL-like interface.
Nice.
So you can write queries to analyze streaming data, just like you would with a traditional database.
Gotcha.
Like, imagine you want to track the performance of your website in real time,
Uh-huh.
looking at things like page load times or error rates.
Yeah, makes sense.
With Rising Wave, you can create those materialized views
Right.
that are constantly updating those metrics
Cool.
based on the data stream coming in.
So it's like having a live performance dashboard for your website.
Exactly.
Always showing you the latest stats.
You got it.
That sounds super useful for, well, anyone who wants to keep a close eye on their online presence.
Absolutely.
Okay, so Flink for complex event processing,
Yep.
Rising Wave for SQL-based analysis.
That's a good way to think about it.
Got it. But with all this power
Yeah,
comes a lot of responsibility, right?
that's true.
We talked about exactly one semantics earlier, which sounds pretty crucial for maintaining data integrity.
For sure.
How do these tools handle that challenge?
You're right. Ensuring exactly once processing is essential, especially when you're dealing with sensitive data or mission-critical applications.
Right.
Both Flink and Rising Wave take this really seriously.
Okay.
They use a variety of techniques to guarantee that each event is processed precisely once,
Wow.
even if there are failures or network interruptions.
So it's like they have a safety net built in
Yeah,
to prevent data loss or duplication.
exactly.
I'm curious, what are some of the specific mechanisms they use to achieve that?
It sounds like a really tough problem to solve. It is, but they both rely on this combination of checkpointing and idempotency.
Checkpointing and idempotency.
Yeah.
Okay, tell me more about those.
So checkpointing is like taking regular snapshots of the system's state
Mhm.
so that if something goes wrong, you can rewind to a previous good state
Interesting.
without losing data,
Gotcha.
It's like saving your progress in a video game.
Right.
If you lose power, you can reload your last save and pick up where you left off.
So checkpointing is like a safety net for the whole system.
Exactly.
What about idempotency? How does that fit in?
Idempotency means that an operation can be executed multiple times without changing the outcome.
Hmm.
Think of it like pressing the elevator button multiple times.
Right.
Doesn't make the elevator come any faster.
Sure.
In the context of streaming data, this means that if an event accidentally gets processed twice,
Yeah.
it won't mess up the final results. Like if you're counting website visits,
Uh-huh.
processing the same visit twice shouldn't inflate your count.
Right.
The system used to be smart enough to recognize that it's already seen that event before.
So idempotency is like a built-in safeguard against accidental duplication.
Yeah, you could say that.
That makes sense, but real-world data,
Yeah.
it's rarely perfect, is it?
It's true.
What happens when events arrive out of order?
Right.
I imagine that could throw a real wrench into the whole streaming process.
It definitely can, and handling out-of-order data is a big challenge for any streaming system.
Okay.
Both Flink and Rising Wave have ways to deal with this.
Right.
One common approach is to use watermarks.
Watermarks. All right, now you've got my attention.
So imagine you're streaming data from a network of sensors,
Okay.
and some readings are delayed because of network issues.
All right, that happens.
A watermark is like a timestamp
Uh-huh.
that indicates how far behind the system is in processing those events.
Okay.
It's like saying, okay, I'm pretty sure I've seen all events up to 2:00 p.m., so I'm
Okay.
going to go ahead and do my calculations based on that.
Gotcha.
If a late event comes in after that watermark has passed,
Yeah.
the system can either ignore it
Okay.
or use special techniques to handle it.
Interesting.
Another approach is to use buffering,
Buffering. Okay.
where late events are temporarily stored until they can be processed in the correct order.
It's like having a holding area for those straggler data points
Exactly.
until they can find their place in the timeline.
You got it.
So watermarks and buffering,
Yeah.
they're like time-traveling tools that help keep the data stream flowing smoothly,
Right.
even when things get out of sync.
Exactly.
That's some seriously clever engineering.
It's pretty neat.
But with all this focus on the technical details,
Yeah,
I want to make sure we don't lose sight of the bigger picture.
sure.
What are some of the key benefits of using streaming databases, what makes them so valuable in today's data-driven world?
One of the biggest benefits is that you can gain insights and make decisions in real time.
Real-time insights.
Well,
Okay.
I've already talked about things like fraud detection, preventative maintenance, and personalized recommendations,
Right.
but the possibilities are pretty much endless.
Yeah, I can imagine.
Like, think about a city using streaming data to optimize traffic flow,
Wow, that would be great.
or a retailer adjusting prices dynamically based on demand,
Interesting.
or a healthcare provider monitoring patient health in real time
Uh-huh.
to provide more personalized care.
It's like having a finger on the pulse of the world,
Yeah.
constantly monitoring and adapting to changing conditions.
Exactly.
That's incredible.
And this real-time responsiveness can give businesses a big advantage,
Makes sense.
letting them react quickly to market changes,
Right.
personalize customer experiences,
Mm-hmm.
and optimize their operations for maximum efficiency.
In a world where data is constantly flowing and decisions need to be made faster than ever,
Yeah,
it sounds like streaming databases are becoming essential.
I think so.
It sounds like they're not just changing how we process data, but also how we do business.
For sure.
It's exciting to think about how this technology will continue to evolve
It
and
is.
what new possibilities it will unlock in the future.
Absolutely.
But before we get too carried away with predictions, I think it would be helpful to look at some concrete examples of how streaming databases are being used today.
Okay.
Can you walk us through some real-world scenarios
Sure.
where these tools are making a tangible difference?
Absolutely. Let's dive into some specific examples next. Okay, so we've talked a lot about the theory and concepts behind streaming databases, but let's see them in action now.
Yeah, let's get down to brass tacks.
Okay.
I'm eager to see how these tools are actually being used,
Right.
to solve real-world problems and make a difference.
Okay, so picture this.
Okay.
You're a marketing manager for a large e-commerce site.
Right.
You need to monitor website traffic, track conversions,
Mm,
understand customer behavior in real time
right.
to make good decisions about your advertising and promotions.
Sounds pretty standard for any online business these days.
Yeah, it is.
So where do streaming databases fit in?
Well, this is where that combo of Kafka and Rising Wave really shines.
Okay.
First, you use Kafka to capture all the relevant data streams like website clicks,
Mm,
product views, purchases, you name it.
so all the good stuff.
Yep, Kafka's like a central hub
Okay.
collecting and organizing that fire hose of data.
So Kafka's like the data plumber, making sure all the information is flowing where it needs to go.
Exactly.
What happens?
That's when Rising Wave comes in.
All right.
You would use its SQL-based interface to create those materialized views that we talked about,
Right.
to aggregate and summarize the data from Kafka.
Gotcha.
For example, you could create a view that tracks the number of unique visitors to a specific product page,
Okay.
all in real time,
Nice.
or another view that calculates the average order value for a particular region.
So Rising Wave is taking that raw data stream from Kafka
Yeah,
and turning it into something meaningful, something you can actually use.
exactly. It's like turning raw ingredients into a finished meal ready to serve.
I like that analogy.
And the best part is, these materialized views are constantly being updated as new data comes in from Kafka.
Wow. So you don't have to wait for reports or anything.
Nope. You have a live, up-to-the-minute view of your business.
It's like having a dashboard that's always on, always showing the latest insights.
Exactly.
I bet that's really valuable for making quick decisions in a fast-paced world.
Absolutely. You could use this real-time data to adjust your advertising bids, personalize your website content, or even trigger those targeted promotions based on what's trending.
Wow, the possibilities are endless.
They really are.
That's a great example of how streaming databases can be used for business intelligence and marketing.
Mm-hmm.
But what about something more technical?
Okay.
Something that really needs that real-time processing,
Sure.
like fraud detection. We talked about that earlier.
Yeah, that's a great example.
Let's say you're a bank
Okay.
and you need to monitor transactions for any fraudulent activity.
Right.
How could you use a streaming database for that?
You could use Apache Flink to build a really sophisticated fraud detection engine
Okay.
that analyzes tons of data points in real time.
Like what kind of data points? What would Flink be looking at?
Things like the transaction amount,
Oh.
the merchant's location,
Hmm.
the cardholder's spending history,
Right.
even their behavior, like how fast they're typing
Right.
or their mouse movements during an online purchase.
So it's not just about simple red flags.
Right,
It's
right.
about using like really advanced algorithms
Yeah.
to spot those subtle patterns that could mean something's up.
Exactly. Flink can process all of that data as it comes in,
That's amazing.
applying machine learning models and rules
Right.
to figure out how risky each transaction is.
Okay.
If it sees a high-risk transaction, boom, it sends out an alert immediately.
So the bank can take action right away.
Exactly. It's like having a digital detective,
I like that.
constantly on the lookout,
Yeah.
analyzing every clue and raising the alarm if something seems off.
And that real-time response is so important when every second counts.
Exactly, especially in the fight against fraud.
Okay, I'm convinced. Streaming databases are powerful tools
They are.
with a huge range of applications.
For sure.
But what does the future hold for this technology?
Yeah.
Where do you see things going in the next few years?
That's a great question.
Yeah.
I think we're only just beginning to see what's possible with streaming databases.
Interesting.
As they get more sophisticated and easier to use,
Right.
I think more and more organizations will start using them across all kinds of industries.
So it's not just for tech giants and data scientists anymore.
Well, it's becoming more accessible to everyone.
That's great.
And as more people start using them, I think we'll see even more innovative applications popping up.
That's exciting.
One area with huge potential is the Internet of Things.
Okay.
As more and more devices get connected,
Yeah.
the amount of streaming data is going to explode.
It's like the whole world is becoming a data stream.
That's a great way to put it.
It's both exciting and a little overwhelming.
It is, but streaming databases give us the tools to harness all of that data
Right.
and turn it into valuable insights.
And actions.
Exactly. We'll see smarter cities, more efficient transportation systems, more personalized healthcare, all sorts of innovations we haven't even thought of yet.
It sounds like we're on the verge of a data revolution.
We are, and it's a really exciting time to be a part of it.
Well, this has been an incredibly enlightening deep dive into the world of streaming databases.
It has.
Thank you so much for sharing your expertise and insights with us.
You're welcome. It's been a great conversation.
And to all our listeners, if you want to keep learning more about this topic,
Yeah,
check out the resources in the show notes
definitely.
and join the conversation online using #TheDeepDive.
We'd love to hear from you.
We'd love to hear your thoughts and
Oh,
questions.
for sure.
Until next time, keep learning, keep exploring, and keep diving deep into the world of data.